Welcome to the next lecture on the course Descriptive Statistics with R software. Up to now, in all the earlier lectures, we handled how to create different types of graphics, and they were the part of the graphical tools of descriptive statistics. From now onwards, we are going to handle the analytical tools, and in unidirection. That means when we have only one variable. When we try to handle more than one variable, then again I will try to introduce the graphical tools in two-dimensional and analytical tools for two-dimensional data. So, the first step after we get the data is that we would like to get some quantified information that is hidden inside the data. As we had discussed, the data is very silent. Data cannot speak. Data cannot tell you, well, I have this value, I have this information. And graphical tools will give you a graphic view, visual information. From that, you have to use your knowledge, your common sense, your information, your statistical knowledge, your information from the experiment, and you need to combine them to get a clear-cut conclusion. Now, we would like to quantify that information. So, when we talk of the information contained inside the data, there can be enormous information which is contained. But our question is, how should we take it out? So, we had discussed that we would try to take the or extract the information on different aspects of information, like as central tendency, variation, symmetry, etc. So, we are going to start it with a new topic in which I am going to discuss the central tendency of the data, and then I will try to discuss different types of tools which are used to extract the information on the central tendency of the data. So, in this lecture I am going to discuss the aspect of arithmetic mean. So, now whenever we try to conduct an experiment, there will be several aspects, and we try to collect the data on those aspects. So, finally, the data set may contain many variables, several variables, and every variable may have many observations. And our basic objective is this: we want to know the information contained inside the data, which is not possible. So, we are trying to develop the tools which can help us in digging out the information from every observation. Now, the question is this: what we would like to have? Suppose I have 100 data points, and every observation tells me something. Or alternative is that instead of having 100 pieces of information, I have a summary information that may provide more information to a common person, and that will be more useful. So, here now we are looking forward to understand some summary measures which can give us the information hidden inside the data on different aspects. Now, let me take a simple example to explain my view. Suppose I want to visit a city, and I have two choices: Lucknow in Uttar Pradesh, which is quite hot during the month of May, it is the summer season, and similarly other city is Srinagar in Jammu and Kashmir, which remains cool during the month of May. So, now we have collected the data on the day temperature of last year on say 5 days, and this data is coming out to be 35 degrees centigrade, 37 degrees centigrade, 36, 40, 38 degrees centigrades for Lucknow, and 20, 18, 17, 22, 23 degrees centigrade for Srinagar. Now, what information I can get from this data? This data can be a large, there can be, means I have taken here only 5 values for the sake of understanding, but these values may be hundred, thousands and even millions. So, from this data I would like to know, for example, that what type of clothing I should take there. In case it is cold, then I would try to take some woolen clothing, and if it is hot, then I would try to take some simple cotton clothings. Right. So, now how to get this information? By looking at this information, yeah, it is telling me that the temperature is quite high and here the temperature is here usually low. But we would like to have a summary information, the information in the summary. Now, what we observe, that is the human tendency to compile the information in terms of averages. For example, in case if I say in a class, some students might have got 45%, somebody has got 55%, somebody has got 65%, and there will be more marks. But then I am more interested in what is the average performance of the class. So, if I say here that the average marks in the subject in a class are 60%, then it makes more sense. Similarly, in case if I am trying to go for a tablet of a medicine, and suppose the shopkeeper or the doctor tells me that this tablet can control the body temperature and bring the temperature down for 6 hours. What does this mean? The doctor is telling us the average value and we are very easily understanding it. This 6 hours cannot always be exactly 6 hours. This may be 5 hours, this may be 7 hours, this may be 5.5 hours, but and this may be 6.5 hours. But this data has been collected and doctor has found a sort of arithmetic mean or an average, and he is convinced that if this medicine is given to a person having a fever, then this tablet can control the body temperature up to 6 hours or say on an average 6 hours. This is what we mean. So, in statistics, this concept refers to as average or the central tendency of the data. Central tendency of the data means, for example, if I have a data which I plot it here like this, then I would try to see what is the point here around which the data is concentrated. For example, here you can see this is trying to give us a central value around which the data is concentrated. In statistics, we have different types of measures to study this central tendency of the data. For example, arithmetic mean, geometric mean, harmonic mean, median, quantiles, mode, etc. So, we are just going to discuss these measures one by one, and I will also try to show you that how to compute them on the R software. So, first let me try to explain the arithmetic mean for an ungrouped data. Ungrouped data means we have a variable here x and we have collected the data on x as say here x1, x2 and so on, say here xn. So, for example, if I say here x is my hair height, then x1 is going to be the height of first person, say 152 centimeters, x2 is going to be the height of second person, say 165 centimeters and so on. And then we have total number of n observations which are denoted by x1, x2, xn, and these x's are small letters. Okay. Now, the arithmetic mean of these observation is defined by like this: x bar is equal to 1 upon n, summation I goes from 1 to n xi. This means I have first to sum x1 plus x2 plus xn, and then I have to divide this sum by here the number of observation n. This is the meaning of this symbol. In order to compute it in R, the command here is mean, and when I write mean and inside the argument x, then my data is contained in the x using the C command. So, let us try to take an example and try to see here. Well, in case if you want to know more about this mean, for example, I will be discussing here another aspect that how to handle the missing values, but there can be trimmed mean also, and there are some more parameters with this command. I would request you to go to the help of mean and then try to look into different parameters. So, now coming back to my example. So, this is the same example that we had considered earlier, that there are 20 participants who participated in a race, and their time in seconds has been recorded here like this, 32 seconds, 35 seconds and so on, and this data has been captured inside a variable here, say here time. Now, in case if I want to find out here this variable, then I simply have to type here mean inside the argument the variable name time, and I get it here as the value 56. So, you can see here this is the screenshot. So, I will try to show you here that how it works on the R console. So, let me store the data over here, so that you can see here this is my here time, and when I try to find out here mean of here time, the variable in which the data is contained, this comes out to be 56. Now, I try to address here one more aspect. If you remember, when we started our course, then in some initial lecture I had given you an idea that there can be many situations where some data might be missing, and this data is represented as capital N and capital A, that is NA, and which is a reserved value. So, in case if the data is missing, then how would you like to compute mean and other components? You see, the way I am going to explain here that how to compute the mean when data is missing, the same concept will be used in all other cases, that you want to find out the variance, standard deviation or the median. The same concept and the same command will be used. So, here I will try to explain in detail, and after that I will quickly take it. So, when some data is missing, then in that case the mean command is used to find out the average value arithmetic mean of the data in x vector here, but there is another parameter which is added here, na dot rm is equal to true, capital T, capital R, capital U, capital E. So, this is trying to tell that please compute the mean after removing the NA values, NA or the missing values. This is what is trying to say. So, in order to understand it, let me take the same example, and you can see here that I have replaced the first two values by NA. I have just made it underlined so that you can easily see it, and so in this case my data vector will contain first two values here as say NA and NA, and in order to store these values I am trying to use here a different name, and this name I am trying to give the time which I had used earlier dot NA. Dot NA is not a reserved word, but this is simply trying to indicate that the data on the time variable that we have used earlier, this is the same data with NA, right. So, in case if I try to do it here, then you can see here if you try to find out the mean only of the time dot NA vector where the data is missing, this will not give you any numerical value, but it will give you simply here as say NA. Why? Because this is going to find out the sum of here NA plus NA plus the value, but the numerical values here 56 plus dot 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 whatever are the values here divided by here 20, right. So, that is why this value is coming out to be NA. You can see here that this NA plus this NA plus this value plus this value plus this value and so on divided by 20. So, definitely this cannot be computed. So, this is giving you NA. Whereas, in case if you try to add here the command NA dot rm is equal to true, then what it is trying to do? It is trying to find out the sum of all the values after removing NA divided by the number of observation, which now becomes here 20 minus 2, that is there are 20 observations and 2 observations are missing. So, this is going to be here 18. So, this number is going to be divided by 18, and now you can see here that this is giving me a value 58.5, where if you recall that the mean of time which it was 56. So, this is now changed because this has been computed after removing the missing value. Now, in case if I try to make this NA dot RM to be here false like as here, then you will see here this is giving me the outcome NA, because actually once you say NA dot RM, this is the default function, and when you are trying to use here the mean of time dot NA, actually this is the default, that here NA dot RM is taking always as say false as a default. So, whenever we are trying to find out the value of the mean, it assumes by default that all the values are available. In case they are not available, you need to inform your R software that yes, there are some values which are not available, and please try to compute the mean after removing those missing values. Okay. Now, this is here the screenshot. I will try to show you on the R console, but before that let me try to show you here that in this case which I just discussed, actually that mean of this time which is containing here 20 values is computed like this, sum of all the 20 values divided by 20, and whose value is coming out to be 56, whereas when you are trying to use the data with missing values, then it is actually based on only 18 values, and this value is coming out to be 58.5. Now, let me first come to R console and try to show you here what's really happening. So, I try to copy this data here. So, you can see here time dot NA has this thing, and now if I try to find out the mean of here time dot NA, this comes out to be here NA. But in case if I try to add here one more parameter NA dot RM is equal to here true, then you can see here this is coming out to be 58.5. This is the same outcome that we have discussed in the slides. Okay, so let me come back to our slides and let us try to have here another aspect. So, up to now we have discussed the arithmetic mean for an ungrouped data. Now, I am going to discuss how to compute the arithmetic mean in case of group data. You remember that in the case of group data, first you need to construct a frequency table. So, now we will learn how to compute the arithmetic mean from the frequency table. So, you may recall that while constructing the frequency table, we had constructed the class interval, and the class intervals were constructed on the basis of given set of data, and they were divided in suitable number of intervals of suitable widths. And these intervals I am denoting as E1 to E2, E2 to E3 and so on, and this part here the first value E1 and here this here E2, in the second case they are called the lower values, and similarly this E2 in the first interval and E3 in the second interval, they are called the upper values of the interval and so on. So, similarly I have created here k classes. So, I have created here k such classes, and then I am trying to find out the midpoint of this interval. So, midpoints of the first interval I am denoting by here m1, which is simply here E1 plus E2 divided by 2. And similarly, the midpoint of the second interval is denoted by m2, which is the lower limit plus upper limit divided by 2 and so on. And similarly, I try to find out the mid values of all the intervals, and based on the given data set, I try to find out the absolute frequency. So, there are n1 values in the first interval, n2 values in the second interval and so on, nk values in the kth interval. And we also know that the sum of all this n1, n2, nk we are trying to denote by here n. And the relative frequency has been obtained, say here f1, which is here n1 upon n, f2 is here n2 upon, and so on here, fk is nk upon n, and is the total frequency, and is here the total frequency. And means obviously, in case if you try to sum all the relative frequencies over here, so this will come out to be sum of all ni's divided by n. So, sum of all ni's here is n. So, this becomes n upon n, which is equal to here 1, which is written here. Right. Now, I would try to define the arithmetic mean for this group data, and it is defined here as say x bar is equal to 1 upon n summation I goes from 1 to k n I m I. So, m I is here the midpoint of the interval. So, now in case if you try to simplify it, so this can be written here as say I goes from 1 to k n I upon n into m I, and so n I upon n is here f I frequency. So, other alternative is that I can simply find it out here as the sum of the product of m I and f I. And based on this, there is another version of this type of mean in case of group data, which is called as say here weighted arithmetic mean. And weighted arithmetic mean is defined as say sum of say w I m I upon say divided by sum of w I, where w i's are the weights which are assigned to the values. Right. So, this is a more generalized function which is useful in many statistical data sets. Now, in case if you want to find out here the arithmetic mean of the group data set, so we know this is now going to be simply here I goes from here 1 to k, which is here say here f I m I. So, if you remember when we were discussing different types of mathematical operation using the R software, then we had discussed that this type of thing can be obtained by say sum of two data vector f into here m, right. So, where f is going to be the data on say f1, f2, fk, and m is going to be the data on say mid values m1, m2, mk. So, in order to do it, this R has already a built-in function which is called as weighted dot mean, weighted dot mean, and inside the arguments I have to give the two vectors here m and f, where m is containing all the midpoints and f is containing all the frequencies. So, obviously, when you want to compute the arithmetic mean of this group data, first objective will be to find out the frequencies, and in order to find out the frequencies, you may recall that we had used the command table, and table will have two types of components. When the first one will be intervals and second will be frequencies. So, we need to extract the frequencies from the outcome of a table command. Now, you have to be watchful here that in this function weighted dot mean, I have used this symbol f to indicate the absolute frequencies, whereas if you observe in this slide, in this formula, I have used here f to indicate the relative frequency. So, now in this example, and in order to compute the weighted mean, I will be using the indicator f to indicate the data vector of absolute frequencies and not the data vector of relative frequencies. So, let me take here an example and show you that how the things are going to work. So, once again this is the same example that I discussed earlier, that there are 20 participants who participated in a race and their time is recorded in seconds, and this data has been recorded here under the variable here time, right. And now, we had converted this data earlier in the form of a frequency table, and you can see here that I have created here the class intervals like this 31 to 40, 41 to 50, 51 to 60 and so on. So, there are altogether 6 class intervals. So, k here is equal to 6, and then I have found the midpoint which is here 31 plus 40 divided by 2 and so on. So, this is the value of here m1, this is the value of here m2 and so on. So, we have here m6, and their absolute frequency have been obtained as here 5 for the first class, 3 for the second class, 3 for the third class and so on. So, these are the value of here f1, f2, f3 and here see here f6, and this is here the value of here sum of all the frequencies which is equal to here n, right. So, now just to give you a brief recall that how we had found the frequency distribution. I have taken some slides from the earlier lecture, and you may recall that first we had defined sequence between 30 to 90 at an interval of 10 by using the command seq, and we had stored this data inside a variable breaks. So, breaks was 30, 40, 50, 60, 70, 80, 90 values, and then we had using the data time and using this data vector here breaks, and putting the right hand side interval to be open, we had used the R command cut to convert the data into factors. So, and this data was stored in time dot cut. So, this outcome was like this. This all we had discussed earlier, right. And based on this time dot cut data, we had found the frequency table of the data in time vector by using table inside the argument time dot cut, and this was the frequency distribution that we had obtained. Right. Now, what we have to do? We need to find out the weighted arithmetic mean or the arithmetic mean for this group data. So, this can be done by the following ways. First step is that we need to extract the frequencies from this frequency table. So, this is here the frequency table, and we want to extract only this data vector 533, 522, because this is the value of f1, this is the value of f2, this is the value of f3, this is the value of f4, this is f5, and this is here f6. So, now in order to do it, we try to operate a command as dot numeric on this frequency table data. So, that will be as dot numeric all in small alphabets, and inside the argument I have to give the data vector, and this data vector is going to be the outcome of the frequency table. So, in this case you can see here your frequency table data is given by table and inside the argument time dot cut. So, I try to operate this command over here as dot numeric and inside the arguments table time dot cut, and this gives me here this outcome. So, you can see here that this data is the same data that you have obtained. Say this 5 is the same as here this 5, this 3 is the same here this 3, and this 3, this is the same here this 3, and this 5, this is here the same 5, and then this 2, this is here the same 2, and this 2, this is here the same 2, right. So, now once we have obtained this here vector here f, which is the vector of the frequencies, similarly we can find out the vector of the data on midpoints, and then I simply have to use here the command weighted dot mean and with m and f, and this will come out to be 56, right. Okay, so, let me now first try to operate this thing on the R console to show you. So, now if you try to see, we already had entered the data on time, which is here. Now, I first need to create a frequency table. So, I will simply try to copy and paste the commands that we had used earlier. So, this is about the breaks, and then I will try to execute the command to get the data time dot cut, and then I will try to find out the frequency table using the time dot cut, and you can see here this is the same data set, and now I will try to extract here the data from this table using the command as numeric. So, you can see here this data is here the same. If you try to see here this line which I am highlighting and this line which I am highlighting, they are the same, right. And now I need to define here the vectors of midpoints. So, this is here m. So, you can see is here m, and now once you try to use here the function or the command weighted mean, this weighted mean come out to be 56. So, this is how you can obtain this weighted mean in case of this grouped data. And now here is the screenshot of the same operation that we have just done. Now, I would like to stop here in this lecture, and if you try to see what we have done, we have simply learned the concept of arithmetic mean, and we have learned how to execute it on the R software. And this arithmetic mean is found for the group data, for the ungrouped data. So, that is pretty simple, but it is more important to learn that what are the different other parameters that can be used in the command mean that can be looked through the help menu. So, I would request all of you that you try to take a small data set, say only few numbers, and try to compute the arithmetic mean by your hand manually, and try to compute it using the R software. And once you see that both the things are matching, then it will give you a more confidence that yes, the software is also doing the same thing what we wanted to do. So, you practice, and we will see you in the next lecture. Till then, goodbye.